And now we'll discuss about TACACS and RADIUS. So TACACS and RADIUS. So this two, or we call this as this is used for device administration. I mean, TACACS is used for device administration. So we'll see exactly what is the packet flow for TACACS. So, I mean, maybe 5-6 years back, they used ACS, Cisco ACS. That is something I am aware of. And they use Aruba POS. And now this being the next generation is Cisco ICE. They call this as an identity service engine. So first we'll discuss about TACACS. So for example, if you got 120 sites, and what happens, you have to have a username and password to log in the boxes. It can be a routers, or it can be a switch, it can be a firewall. So there are many ways to authenticate, and TACACS is purely for device administration. And if you've got 120 sites and you got 300 plus, or maybe 3000 plus appliances, you have to create your local username and password for every appliances. So from the management perspective, it's too difficult to configure every single device. And the other disadvantage of using the local username and password is you cannot do accounting. Accounting is who logged in this box and what he is doing, what kind of commands he is executing. So those kind of accounting you cannot do with the help of local username and password. So I need a device where I can do a central administration for all these appliances. And I want to do accounting specifically. And I know who is accessing when, and what is the time frame, timestamps. So you'll get to know about all this information. It's all being dumped inside your Cisco ICE. So here you're running a feature called TACACS plus feature. So what you'll do, you will add up all your 3000 appliances, or how many appliances you have at your site. It depends on the number of appliances you're going to use. You're going to add all these appliances, and the key thing is you have to configure your TACACS configuration. So you have to define your TACACS server. Example, if my TACACS server is 10.0.0.1, so you're going to define your TACACS server as 10.0.0.1 here. For all these appliances, you're going to do your TACACS configuration. And the key thing is you're going to use your shared secret. Example, it is Cisco at 123. So you have to define the same shared secret for every single appliances you add in your in your ICE. So once this is added, so whenever there is an authentication, when you do authentication from your jump box, so when you try to access this particular IP address, if your management IP address something like 20.0.0.2, so there is request source, it comes from 20.0.0.2, and it will relay back to your TACACS server. And when you type your username and password, your shared secret will be exchanged between this appliance and to your Cisco device. And from your jump box to your device is unencrypted. Whereas from your Cisco box to your TACACS server, that is encrypted. So when somebody sniffs the traffic between these two, you cannot see anything. So the logic is simple. So they'll be running a profile. So you'll be given with privilege level 15. So that is something you can access everything. You got read and write access. So that is purely based on your policy set. So whatever the policy you define in your TACACS. Example, inside your policy sets, you declare something like, so your network engineer group. So that is again, this is integrated with the help of LDAP. So inside your LDAP, you got a group called network engineers, and your username is something like A, B, C, D. So when a request comes from your jump box, and if you type your username and password, so in the backend, your Cisco ICE will query your LDAP, and it will look for this credential A, B, C, D. And if it matches inside your policy sets, you would have defined your privilege level as 15. That is shell privilege to access your CLI. So this is returned back to this user, and now he can successfully log in. And usually when you do the TACACS configuration, it is always recommended to use a fallback option. So the first primary authentication should be for your TACACS authentication. If TACACS is not authenticated, or if TACACS is down, so your local credential is used to log in your box. So if you go and if you manipulate your shared secret, and if you make a manual disconnection for testing, so you cannot log in the box using your TACACS credential. You should log in your box only with your local credentials. So it is always recommended to use a fallback, and two key things. So what is a kind of authentication mechanism you use? Authentication, your authorization policy. So you've been given with a privilege level 15, that is your authorization. So authentication, I am using TACACS authentication. And accounting is who logged in, when he logged in, what kind of commands he is running. So all this information is dumped back inside your ICE. And if you go to your ICE and if you look for TACACS live logs, you will see all this information. So is it my authentication is successful, and what are the key attributes that's being exchanged between the network appliance and the Cisco ICE. And in the Wireshark, I'll tell you, so you can also decrypt this information in Wireshark. So for that, you have to go to your TACACS, edit preferences. You have to go to your protocol. You have to go to your TACACS plus. So you have to give your encryption key here. So once you do this, you can decrypt your TACACS. So we are not doing decryption here. So here it is just a query, and I get a query response from this server. So authentication, authorization, and accounting is not configured here. So authentication and authorization is successful between the source and destination. So all an encrypted reply. So this is a server, because the port number used by the server is 49, and this is a random port generated by the PC. And I got a reply from this server for authorization. So you can verify that. So all this is a request from the client. 192.168.1.32 and 192.168.1.5 is a server. So it's giving a response for the authentication. And if you decrypt, you will see, is it your connection is successful or it is failed. So for every TACACS authentication, it uses a session ID. So I can see the SYN and ACK here. So my connection is successful. So once the user typed in and he finished everything, he sends a FIN, and I get a FIN ACK from the server. So it's a gracefully closing this connection. So this connection is successful between client and server. I come to know about this. Source port is a random port 59087, and for the destination is a server, it's 49. So this is not about deep dive about TACACS, but this is the packet flow, and we'll see how the packet flow looks like inside. So if you see this, so this is a device, network appliances, we call this a NAS. So all your user traffic to the NAS jump box, if you log in, so that is not encrypted, but from the network appliance and the TACACS, all this information are encrypted. So it's going to send an authentication request, and I get an authentication reply back with authorization level. If you're given with 15, that's a full access. And if you got write-only access, read-only access, sorry, your privilege shell value will be minimal, and you cannot do any changes with the devices. So then again, authorization request, where your shell privileges will be exchanged. In the authorization reply, it's going to say your privilege level is 15, and it's an accounting packet again. So or whatever the commands you run on this particular devices, that's been dumped back inside your TACACS logs. And the server uses a port number 49 for the same. So all your passwords, username and password will be encrypted. So this is called this three process. I mean the three key. The three key parameters used are authentication, authorization, and accounting. And it is a central management for authorization configuration. That is the main use of it. And it is used for network administrators to access the device. In the same way, for device administration, we can also use a radius authentication. So it encrypts only the password, and it uses a UDP port 1645 and 1812, and it depends on the operating system. And every network device should have this authorization configuration that should be done inside. So that is applicable for both. So you can also configure active, passive, or maybe failover scenarios. Example, you can configure both TACACS servers. It depends on the deployment. If primary fails, the request goes to your secondary. So you have to create a TACACS group, and you have to define your primary and secondary for the same. So both does the same job, but here only the password is encrypted. Here your username and password both are encrypted, and there is very minimal vendor support for radius. And for if you have an eyes for your controller and for other purpose, then you can definitely make use of TACACS. And if you want to see the config inside, as I said, you should keep AAA authentication login, and you have to give your TACACS group if you have multiple TACACS servers inside. And this is a group, a TACACS server, and this is the IP address of it. And if you're using a shared secret, you have to define your shared secret key inside. And AAA new model is for Cisco appliance. This is a key command to enable your AAA authentication. That is, if it's want to support authentication, authorization, accounting, you have to enable this globally. Then you have to define your TACACS server. Then followed by that, you have to define your TACACS server name. And in the authentication group, the first primary group is your TACACS group. And if it fails, it has to look for your local credential. And you have to define this under your terminal connection, VTY, virtual terminal line, and you have to define your authentication policy inside. So this is pretty simple config. And for accounting, you can define your authorization levels. So I have to do whatever the commands, it starts from privilege level 1 to 15. Whatever the commands you use, that will be the accounting information will be dumped back to your TACACS server. So this is for the TACACS authentication. And when you use, when we talk about the radius, and if you use any kind of certificate-based authentication, let's come for the radius. So the very first message, it starts from the client is EOPL. It's over the LAN. It is extensible authentication protocol. And if I send an EAP request, so all this information is not encrypted between the client and server. So the EOPL packets is only between the appliance and the client in client. And the radius request is from the network appliance to the ICE, or maybe whatever the authentication server use. So this is generally a radius access request, and you get a radius access challenge message. And again, the appliance will send back the radius access request again, and I'll get a radius access accepted message. So you are authenticated and you can access the devices. So in the EOPL, we are not going too deep about EOPL here because it's primarily for TACACS. And if your EAP messages is successful, that is something you have to configure your EAP, and your port should be open for EAP. Only after your successful EAP communication, all your data traffic and other traffic will be exchanged. So this is about radius and TACACS. And the final piece we want to discuss about today is how when we have a problem with a slow throughput issue, so how we are going to find that. And along with that, some of the graphs we make use of, and we apply some filters. Let me open it. So this is one of the window problem we got. We discussed about calculated window size. If your window size is squeezing, there is something problem. Then the amount of traffic that's going to receive, that the buffer is squeezing. So you'll definitely observe the slowness and throughput issue here. So if you look at this particular capture, and if I drill down, if you look at this particular the window size, and if you go to scaling factor, you can see this, right? So in the scaling factor, you can see it's decremented, it's -1. So if you see the previous window size is 65,160, and if you differentiate this, if you go to this particular packet, so my window scaling factor is not increasing at all. Why is that? We seen in the early, in the normal captures, the window scaling factor should be incremented. And we see that how exactly the calculated window size is calculated before. But here it is not incrementing. And if I keep drill down this, and I see this being squeezed out and no data is exchanged, and it is just 3,567. And if I go to statistics, TCP stream graph, and if I go to Stephens graph, so you should see a ladder-like option here, and it should be continuous, something like this. So here there is no choppy traffic, but if you see, there is no traffic that's being sent. If you see in the middle, there is no traffic it's being sent. So it should be something like a steep ladder that's going towards upward. So this is here, this particular time frame, I don't see any traffic that's going between. So this is because of a window size problem. So using the TCP Stephens graph, you can find. So if you try to find any other captures, I go to my PCAP. And if I look at this, if I go to statistics, so if I zoom, this is not actually a huge number of packets that's being exchanged. Let's go to a PCAP. Let's see this VoIP traffic. Here we are not using TCP. Let me take any other capture for it. EBGP, this is TCP. So I think this is all very minimal statistic. So that is especially for upload, download. If you do a live capture for it. It's all not really in application traffic, it's all encrypted. Let's do a capture. It is generally, it is used for your upload and download. You should say send really a huge amount of traffic. Set something, I'm establishing a connection. Let me do an IPUF